So we probably should say the batteries went flat.
The batteries went flat, and we went and we ate food.
And the battery and the sound went flat, so there may been some dodgy sound before.
There's going to be a hollow section in the middle where the sound is horrible, and I apologise for that. But also, I don't know how long it'll be.
Yeah, and I'll flag it when I'm editing it. I'll go, oh, okay, now the sound sucks.
Yeah, exactly. And then it's fine. You're fine. All right. Cool. So where were we up to? Oh, a murder was just about to happen. A murder. Okay, great. So, before anything, no matter how the murder ends up looking and functioning, it's at this point, before everyone gathers, that the murder's going to happen. So, it would be a semi-random system to decide who gets murdered. So, I've got 6 possible characters. And I imagine it would work something like... Okay. Wait.
Well, it can't be the imposters.
Yeah, it can't be the imposters. But I imagine it would work kind of like when we were rolling for the imposters and I had to roll multiple times because it kept hitting a character who already had that flag, right? So I imagine it would work in a similar way. It would still be like running through the 6. If it chooses someone who's not a valid option, it would just roll again, right?
Yep, got a loop.
Okay. Cool. So 3 is a valid option. 3 is this character, and they have the smallest, the worst score with you. And I said in the first video, way back when,
you want to keep them,
that I would keep your favourite character and your least favourite character just for the drama.
So that would make that an invalid choice.
That's an invalid choice. So we'd roll again. 2 is pink. Pink is somewhere in the middle of points, so pink can die. Ha ha ha! I'm making a dead post-it.
Symbolically in red.
Yeah, I'm just going to make it a skull and crossbones. Yeah. There we go, that's good. So pink is murdered. However that looks like, pink has been murdered. Alright. Okay. Now what? Where's my phone? Did I leave it upstairs? I think I did, so I'm just going to have to remember what the hell my game looks like. So, cue a scene which probably in many ways is similar to these, wherein you discover the body and talk about the body and don't know, isn't this terrible?
But didn't you say that then, so what triggers everyone going to, and then discovering one's missing? Because you said...
Yeah, so that would be... So I suggested that would be, for example, everyone shows up in... So this is one way that it could look, but it could look different ways. Much like entering a room could look different ways.
What triggers that? What motivation do these people have to suddenly decide they're all going to get together?
Well, in the storyline, it would be, okay, we're ready to leave for the mission. So they all get together at the hangar where the so they're on a space station.
So, all right, for that to happen, you got 2 ways it can go. Mm-hmm. You can have it that there is a set number of interactions, mm-hmm. and after that number of interactions, we know that someone will have been murdered.
Right.
And so...
Could I have it as once you've interacted with everyone?
You could. So you could have a list, and then... So you could have it so that there is the list of all characters, mm-hmm. and you flag off, you've got a copy of that list.
Well, maybe you don't even have to speak to every character. Maybe it's just after you've visited every location. Something like that.
So it does look like we are going to have something that's us in the game. Remember we said we could...
Right. But because in order to signify that you have been to those places.
So for the character... Now, in my discussion that I had off camera, where I was saying that this is why you have different types of...
Yeah.
I talked about a program that I wrote years ago where we had queues, and I used a standard template library queue, mm-hmm. but we had different types, and some were never empty and some were never full. Right. So, but they were all queues, and they didn't look particularly like each other. The input queue didn't even have a queue in it, and the output queue didn't need one. But the ones in between, but I call them all queues because they're a queue.
Right.
And programmatically it made it easier.
Yeah. And I see now how me could have attributes. Because we've got these characters have these attributes, and I was like, but none of these fit. But me clearly has different attributes.
What rooms have you been to?
Yeah, so like
who have you interacted with?
Talked, you know. I don't know what exactly I would call those things, but you know, they've got, instead of having like a growing, you know, integer for their affinity or whatever, they've got maybe a growing integer of number of rooms visited, or you know, whatever.
Well, you probably you probably want to have, unless you've got different ways that it can be run. You can have an all-knowing world that moves the characters around, or you can have characters that know where they're supposed to be.
Right.
And intuitively, I like my objects to be as smart as they can be.
Right.
In a sense.
No, okay, here are the things that I've just thought of. So we just very, very smoothly did the, you know, you know, so-and-so, who was it? It was orange is invalid as an option for murder because they're your least favourite person. But it did occur to me that there would need to be some kind of a thing that actually compares all these numbers and goes, that's the least popular one and this one's the most popular one. And I don't know how to do that, but it is something that I felt like I should actually say,
but that's part of the algorithm.
Yeah, because our brains filled in the gaps there when we were doing it.
But what happens is then, this is as we flesh it out, so you start up with high level pseudocode.
Okay, so like, you know.
And the pseudocode would be work out, based on indexing, work out who can be murdered.
Right, and then individually.
And then when you actually go
affinity values, blah blah blah. Okay.
And so you break it down, and you start up with very high level, overarching sort of pseudocode, and then you block in and you fill in until. Over time, you so you get it to a thing where you might write something that it just automatically, when you're first trying to try it, you don't want to write the whole game and then push run.
Right.
So you'll get it. So you start off with this really basic thing, and then you have it. So you push, you run, and it'll just print out.
Right.
It'll just print out. Went to location, ask questions, and it'll flag these things, and you just get it so it prints out the screen.
Gotcha.
And then it'll come up and say, ask questions. You go, that's right, that's what I want to happen. So you can turn your code, your pseudocode, you get it, you start building your objects, and then inside of your objects, then you have, all right, ask question or menu or whatever. And then inside of that menu thing, initially, you don't write the whole thing, it just presents a menu.
Right, so it's like you're zooming in over time.
And so then you can start off your program testing, and it just goes up, and in the broadcast, and it says, games, you just choose a room. It says you choose a room, and then any key to continue, and you don't actually choose a room. Right. And it goes, and then it goes into a room, and then it says ask questions and whatever. And so you can get it so the program runs,
right,
and it just prints out what it is, and then you go, okay, what's this look like? And then instead of just having a comment saying work out score, work out relative popularity, work out who can be murdered, or whatever the appropriate pseudocode is. You then go in and you go, right, I want to do that now. And you focus in on that one thing. And you then figure out line by line. And so then you write pseudocode in there. And then you write that. And those pseudocode you write as comments. And then you fill in underneath the comments and you write the real code. So then you get really nicely documented code that when you look at it, it says, in the bottom, in the function, you use 3 single quotes and writes it. And then when you mouse over in the development environment, it'll show you this object is called this, it does these properties, and you can put in this whole description, and you mouse over it, you can see it. Nice. So you write down, so you create a class, and then in the class, at the top of the class, you put one of those comments in the constructor, and then you've got the methods inside of it, and you've got the properties and so forth, well, in the methods, and inside of the method, you write a comment on the top of each of those. And so now you can just look at your code and you follow away. And when you go in there, it says this function, which is well named, so it really explains what it does. And it lists what all the parameters that you pass into it are, and it says what they all mean, but they're all well named, so they're obvious anyway. And then when you're writing your code and you start typing that, you can mouse over it, and it'll tell you what all the parameters you need to pass in and what the value, but that's up to you to do it. And if you write code like that, then you don't have to keep looking around and whatever, So there's these tools that are built into the language, and then it just fills out and fills out and fills out. And then you get to a point where you go, now I can run it, but that running it has got all these things that just print out something on the screen saying, yeah, I did this thing.
Okay.
And then it comes back and then you go, now I'm going to work out, I'm going to do that. So you break the problem down, and you're only solving this little bit of the part of the problem. And now okay, what's the best way to do that? What's the algorithm that's going to work well for that? And then when you've got that, and then you come back out, and you're not trying to think of 17 things at once.
See, that's good. The next thing I thought of was that I should have realized much sooner that me was going to end up being a character, because if this was a board game, you would need a player piece for yourself to know where you are. So there you go. So even though it doesn't have the character cards that the others have, still. Anyway.
Is that Raven singing?
I think probably. Yes, it is. Okay. Now, in terms of the narrative of what's happening next, I wrote it down because I don't have my phone. So they're going to find the body.
Yeah.
Then there's probably going to be another round of conversations very similar to, this throwaway menu. But it will be in terms of gathering information and whatever. So less of the emphasis on the point values and affinity changes. There might be a little bit of that, but it's mostly just information gathering, but it works the same way as that does. And then after that, we would get our next big thing that we have to do stuff for, because then you have to decide whether or not you're going to throw someone out the airlock. Right. So would that just look like, well, do you want to throw someone out the airlock? Here's a list of all the characters that you can throw out the airlock, and another option for no one. Would it just look like that?
It's just another menu.
It would just be another menu, right? And so then you would throw someone out the airlock, and you can make your choice.
See, now, this is saying to me that a menu is looking like a very good object. Because every interaction, you need a menu. Now,
it's also looking to me, with my one class of game design, like the core loop of the game is, prompt, options, choose your response, then they have another
There's
response
your
back.
algorithm.
Hey, the algorithm is the loop. Okay.
It's the program flow.
Gotcha. Okay. So wait, I'm gonna keep a list somewhere of I probably should just do it on the thing, but up here I'm just gonna.
No, not up there.
Oh, jeez.
Although we can pull this down a little bit.
No. I'll just keep it in my head for now and on video so that I can remember it later. So at the moment, our objects, our classes of objects.
Well, so remember our class and object. Class is a description of a dog.
Yeah.
And then Fido is.
Okay.
Right?
Okay.
Character is the class.
Is an object.
But black is an object of type class character.
Right. Okay. And so then each
and
menu...
purple is an object of type class character.
Okay, so then we would have a lot of different menu objects.
Character.
Right.
Now,
so we would have a lot of different throwaway menu objects within the class menu.
Well, an object, a menu is something you can use. Like, give me a knife.
Yeah, right.
And you've got a drawer full of knives.
Right.
So whenever we need to ask a question, we can either have a menu that's been created and the world holds, and we refer to, or is inside of there, or every you can have if you're the one all the time who is doing the asking and answering, and you have to be there, then
so
then
you
you
could
just
cache
have
them within me.
yeah.
Oh.
So
me
you
has
are gonna
menus.
so a menu.
So it's because scene has dropped off as scene is not a thing anymore, or you know what I mean. So at that point, because before I was like, oh well, scenes have menus, but now it's me is a part of scenes and me has menus.
And menus are the way that you respond to. You can ask via a menu and you can answer via a menu.
Right. Okay.
Now it might be the way you're describing it that this character here, you might have the menu that you can see, and they might put up a thing and there's a set of responses based on, or you might have them, but it could be both. Right. So this in the scenario, black says something hugely funny.
Whatever it is. Purple says
sarcastic, right? Now, that happens, and then you inside the game presents you, maybe the game, maybe the world.
So you could
offers you the menu, right? So you can then respond to it.
Right. So you could almost as if you're splitting it up. So I'm thinking of it as like one thing that's like, here's a prompt and here are the options. But it could be kind of like black owns the prompt, I own the menu of reply options.
Well, black provides.
Yeah.
Well, but I mean, this is where you have to decide, is it always either sarcastic, honest or clever?
No.
So there's going to be something that has to determine what these options are depending on the circumstance.
So it could be the triggering dialogue. It could be, okay, so it's like if this piece of dialogue is the trigger for this
or
menu.
it could be if it is this character.
Right.
This character has an affinity with these sorts of,
Right.
They're going to make these sorts of things. So if they make a sarcastic comment, then these are the sorts of valid replies.
Right.
So there's these pairings of a type of comment and a type of reply.
Right.
And so you have to work out algorithmically how that works. And all of that will be ultimately stored in CSV files. To keep it simple, there are, like I said, there's much more. If you go into games, a lot of the time they'll have XML or they'll have, there's standard ways of storing those things. But for simplicity, I think we stay with CSV. But you can have collections of them.
Okay.
And they can be sorted. And if there is this type of question, then these are the prompts. And these type of questions, these are the prompts. And this is where maybe CSV isn't the best, because XML you can have embeddeds, and you can have a something, and then this type, and then have this many. So and you can have subgrouping and that sort of stuff. We'll have to work that through.
Right.
But it's a matter of. But we start simple.
Yeah.
But this is. I think that what we've basically got though is we can see that there has to be a way. So once you've written and you include in your code, and if you need it in more than one place, if black needs menus and purple needs menus and these one, if they need one, you put one into that class, and every time you create purple or black or white, automatically they'll get a menu that they can interact with.
Yeah.
They maybe for them, their thing is it's more of a prompt, and it's a comment that they get to make. And then when that comment comes in, based on that type of comment, if the comment comes in and is flagged as a sarcastic comment, then there's a menu that presents to you of options that you do choose when it's a sarcastic comment.
Right.
If it's a friendly comment, there's another set. If it's an angry comment, then if it's a defensive comment.
Right.
So based on the type of comment, then there's going to be a set of, so you're going to have a grouping. This type of comment is going to have these sorts of valid, you can be sarcastic, you can be honest, you can be clever.
Right.
And then there's these, but this is where it gets more nuanced. And nothing is intrinsically complicated, but by the time you play them out, they become.
Right.
But if you write it well, no individual part of it is complicated.
Right.
It's trying to get your head around the whole thing. But this is where, and I would say that maybe if we're working toward a point for the end of this series of this chapter of videos, if you made up a board game, and made up pieces and convinced someone in your family, no, you don't even need to do that. You can do it yourself. Because you're not interacting with anyone else. So you play your hand and then you think, I'm the computer, what happens next? So you don't even need input from someone else. You don't need to play, it's a single player game.
It would have to work as a single player, yeah.
It's a single player game. So if you can create and role play and note and effectively write a set of rules, and the rules are down to, so the first thing we established is we create this world, and the world has 1 to n locations, and in those locations have 1 to n characters. And those characters have likes and dislikes, and then they have these scoring, affinities. And so, what are they all? And then you say, so basically anything that you do is a prompt asking you and you responding to it, because that's your only interaction.
Yeah.
And when you get into the better game, it'll be a graphical thing with a bunch of buttons or checkboxes or something, and you push the button next to the one you want. But it doesn't have to be that initially. It's just, so this is where too, by starting this way, we've got an object that is the menu, and initially when we're working this out, that menu is just writing out text on a screen, and the input is just writing a number and pressing enter. But then down the road, when we want this to take this to the next level, if we think this is a fun thing in learning how to program, and we don't go with RenPy or Godot or whatever the appropriate one is, which might be a choice, it might be a fun exercise to do, if this is about as much about learning to program as it is about the game, then you've got an object here that initially just interacts through the text on the screen. But then now we've got it all flowing and it all works really well and it's great and everything. You go, actually it'd be really nice if we could put this onto a form. Then the menu, now instead of writing to a black screen with text and take input, it displays a form, and that form has buttons on it, and the buttons have text, or it has text and checkbox or radio button or something like that, and then you select the one you want, and then you push OK, and then when you push OK, it comes back, and that's how it interacts. Right. So someone will sit there with a mouse, and then when there's a character and you go into a room, there's a form, and the form displays the images for the characters that are in the room on the screen. But initially, it just says Jack, Steve, and Mary are in the room, or red, green, and purple are in the room, whatever it is. But then, algorithmically, that's fine. It can just print it out. But then when the program's running, you then go, okay, we'll use Qt5 is what I'm using now for my interfaces. And we work out in Qt, okay, here's a form. and on that form we want to have frames for this many photos, and then you add to your character the type with referring to the JPEG that represents each of them. You got a directory full of the images, and the file is called purple.jpg, red.jpg, white.jpg. And when it comes in, it opens up the file that is appropriate, and it links to that file, and then when you walk into the room, it goes bing, 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 and writes it. Instead of saying red, green, and purple in the room, it goes red, green, purple. So you start off at this low level. You start off even with a non-functional game where it just tells you, yes, I've done this, yes, I've done that, yes, and you can see that algorithmically it's flowing the way you want. And they go, now what I'd really like to do now is get those menus working. And then you go into the menus and you start then filling in whatever the input is that it needs, and working out the relationships with those and getting them so that they all are associated, right? And then as you do that, you'll go, okay, this is so what you'll do is you'll say, initially I think it's going to look like this, but when you do it, you go, man, I did get lost for a moment there. I don't know what happened, but anyway, yeah. But you then cache it out. But if you've got it compartmentalised, what you do, this is where top down starts to break up. So if you do that and you go, I'm not really sure about the way I like that, but you've initialised over here, and then you have to go back and ding, 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 all over the place to get the change through.
Right.
Whereas if you've really compartmentalised, it's called encapsulation and data hiding. Okay. So you imagine that your objects are encapsulated. There's a wall around them, and by default, anything inside of it can't be seen by anyone else. But you can set it up so you can go, well, you can ask me this, and I'll answer. But it can't directly look. It can only ask through this wall around the object. And so you come in and you ask, and it'll say, this is the answer, but you didn't ever see directly inside. Which means that you could set it up to live, for example. Ask score. But if their trustworthiness rating is low, the internal score that it knows there is over here, but no one can directly look at it from outside. You can never look directly in. All you can do is ask the character, and if the character's trustworthy rating is low, then it'll come back and say, oh, this is my score, but you can break that connection.
Right. Nice.
And you can return something that's just a random, but by breaking these things up and keeping these things really tight, then you realise that the menu thing's not really working properly, and the menu's not buried in prompt over here, prompt over here, prompt over here, and you have to go to every place you do it and go, oh, instead of doing it this way, you do it that way. No, you've got a menu object, you change that one menu object, and without doing anything, when this character and this character and this character interact with that menu, they interact with one menu that's written in one place, and you change it once and it's fixed everywhere.
Right.
And so, and if you change it from being, prompting on text on the screen to being buttons on a menu, you do not have to touch anything inside of here.
Okay.
Because this doesn't care. It just knows it is a menu, and it can ask this question, and again, it's going to get an answer.
Right.
And exactly what mechanism it takes to ask the question and get the answer, what that looks like, it doesn't care.
Right. Okay.
So we write one menu, but then that menu can be used, and you can ask for multiple instances of a menu, same as you've got a character and you've got 8 different instances of that character. But the code is exactly the same, but this one's name is black, and it's got this, it's this honest, it's this badass, it's this silly. And this one is, but these have all got exactly the same properties, and they can interact in exactly the same way. So you write one class.
Right.
And then you say, give me a class of this, I want to make an object, you instantiate an object, you make an instance of an object, and you say, this one's called orange, it's got this much seriousness, this much silliness, this much...
Which is why I can start with these 6 characters and later on expand that to...
As many as you want.
I need.
And if you know, if we put this game up on GitHub and people could download it, then once you've got that in, they could edit their own character.cfg file or whatever. And if they put in all the... And in fact, when you look at things like those RenPy and whatever, that's what they'll be doing, is they've done all of this. And then you get to write your own parameters. So there'll be input files and you edit those and then it plays out.
Uh-huh.
But this is what's going under the skin probably of RenPy.
Nice. Okay, alright, okay. That makes sense. Alright, so we've had a murder, we've talked to everyone, we've made our choice about whether we're going to kill someone. I'm going to assume that me as the player probably won't kill purple because we like them the best, even because we don't know that they're the imposter. So we're probably, but having said that, white was in the lab with pink. We probably blame white and we throw them out the airlock, and they get a dead marker that this time, because it's airlock not murder, bypasses this and the whatevers, the parameters that we set before. So it bypasses that, and white is just dead. Okay, and then basically it all starts again in a bigger loop, and you go back to, oh, we're going about our daily tasks and we're doing our things.
Where am I going to go now?
Who do I like the most? Although, yeah. So then it just goes back to the top and you go through again.
So there's going to be some sort of a loop that is and that loop can execute with nuances based on if this is the first time, and you've got to, how many times I've been around, how many rounds of conversation I've had. So if it's the first time around, then you might have these sorts of things. But if it's second time around, you add in some bits about previous knowledge and preferences.
Cool. So that's like the basics of it then.
Yeah.
And then, so I assume these characters just hang around, but various things.
Well, no,
will be like as in the character, the object within the character class of white and pink doesn't disappear, but now it just has a flag on it that says
it
dead.
can. And I talked about null. As it, remember when we were talking about ASCII, and we were saying, what are these extra characters? And one of them was null. Mm-hmm. Well, if you set something to null, in VB it's nothing.
So you can disappear a character halfway through.
See, this is another thing about... I
can actually kill them,
yeah,
basically.
Yeah.
I can actually kill them.
So there is... in programming, there are... When you start using objects, you can start using pointers. So, and then you can have dynamic allocation. So you can come in and you can, on runtime, like when you first start programming normally, you'll say, look, we want a list of up to, you just have an array in C++, it's called. And in an array, you go, give me an array and give me 20 elements. So that's the most. And then and then you have 20 and you fill it out with blank characters. So now we've got a list of 20 characters that you have got to get their names assigned and so forth. But then when you get into object-oriented and you start using what are called pointers, you can... Okay, how far do we go? In computers, there's stack memory and there's heap memory.
Okay.
I mean, if we're doing this as a programmer, these things, this really does matter.
I mean, you've mentioned Stack Overflow problems multiple times today. So
this is a stack.
It sure is.
Right? So we've got a stack and we call something and we go, we need a bit of memory for that. And there's this much is available, this is all you got. And then you push onto the stack. Another one. And then we push onto the stack. And then we push onto the stack.
Okay.
And then we pop off the stack. and then we pop off the stack, and then we push onto the stack, and onto the stack.
Why did they decide on the word pop instead of the word pull? Widely regarded as the actual opposite of the word push.
It's pop, right?
Choices were made.
So as you're running the program, and you start, here's the main function. Your program started, and it grabs some memory off the stack, and there's that. Now it says, I need a chunk of, this one's my list of, this is the stuff for my locations.
Right.
Or my world. And these ones are locations, whatever. And they get, when it comes in, these are called automatic variables.
Okay.
And it comes in as, and when you say, give me a world, it says, okay, what resources do I need? So it grabs, it says, this is this big, this is big, this big, this is this big. And so the stack, there's this stack memory, which is just noughts and ones, but it's allocated and managed. And it says, I need this much. And if you're doing it statically with automatic variables, it says, this is how much I need. And so that uses this much of the stack memory. And then you go, and now I need this. And then there's another bit put on the stack. And there's another bit. So this is now, it goes in, and it goes into a location. And the location says, I need this much. And so it's got that, and that uses that much stack memory. And then you go in, and there's a character, and these all get pushed onto the stack. And so as the program's running, it goes in, and then it goes into a location, but now it goes out of the location. That comes off the stack.
Okay.
That comes off the stack. And now it comes in, and there's another location, and another location. But because there is a maximum amount of stack that you've got, you get to this point, and it goes stack overflow.
Right.
I don't have that much memory.
Right.
It's too big. Way back when, that might be quite quickly.
Right.
Now you get, each process gets allocated a certain amount of stack. And you can go in and say, I need a large stack for this one, and whatever. So there's parameters you can ask for if you're compiling. There's certain things you could tell the compiler. And also when you run the program on some operating systems, you can specify that you give this a large, but there's things you can do. But basically, normally you don't ever have to do that, right? Now where it really becomes a big problem, and I will draw this.
Goodbye. We got a long way to go actually before we get out of here. Get out of here.
All right.
Hey, that works.
We come in.
Wait, we got to go further down. We got to post it.
Oh, right.
Get out of there. Get out of there.
All right.
Make it work.
Give me the black. I don't.
Oh,
I want to stack on them.
Fine.
All right. So
Fine.
we come in, and this is main, right?
Okay.
And this is.
That says main?
Yeah. And then that says def main, and inside of there it says self.
Okay.
Right. If it's class. Probably doesn't. And then, isn't it funny? In C++ you go yink, but in this you don't. All right. So now, inside of here, over here you've got a function, and that function is called menu, right? And so in here, you go menu, and then you give it a set of arguments, what you want to have on the menu, right? So that calls over here, right? And that does the menu thing.
Okay.
And if you then wrote at the end of that main call, then it goes back to here, but it creates a new main function. Because every time when it comes in, it creates this main function. It comes in and it goes menu.
So wait, it recreates it every time? So when it loops,
when the program runs, so it starts, and here's your stack, right? And on the bottom, it puts a function main, right? And then you call this, and now it pushes onto there a menu.
Because I've been thinking about it in terms of in music when you hit I'm sure it has a fancy name, but the bars with the dots and you just
repeat.
Loop back and repeat. It's just
called
a
repeat.
I thought it might have been, but when you get a repeat in music and it literally just bounces you back.
Yeah.
And then the next time you just run through, right? But
And then at the other end you got.
But rather than, but it's not just reading the same thing.
1, 2, 3, 4, 5.
So it's not just like in music, you're just reading the same thing again, but it doesn't need to rewrite the music. Whereas in this, it's recreating it.
So what happens is, it comes in, and there's code, and in main it's got a few different things, right? And it's so the program looks at this and says, I need this much memory. So it grabs from the stack this much memory, and it's got its own set of. If that main has got a world, right, and you ask for a world, right, then it comes over and it looks, what's a world? And it says, I need this much memory for a world. So inside a main, it's got this much memory here for a world, and then it's got this much memory for whatever, and it builds up to this much memory. Now our stack is only that's the stack we've got to work with, right?
Right.
So then it calls menu, and menu just needs this much memory. Menu, and then if you just let this finish, when it gets to the end of the instructions in here, it'll just end and then come back to where it was, where you called menu. It'll just come back to this point. At that point, this menu gets popped off the stack.
Okay.
And given it's okay. That's now
it's
free for use. But if you then in here explicitly called main. It would come back here and it says, oh, I need a function main. So it would now...
So instead of popping off the stack,
it creates another
It pushes
main,
onto the stack
right?
again.
And then it comes into here and that says, I want a menu.
Again.
And then it calls back and you get another main and another menu and another main. And every time you go around, you're adding to the stack. And you're never coming off the stack. And then you hit here and you get a stack overflow.
Right. Okay.
Right? So you don't, this is called recursion.
Okay.
When you get a loop, you can even have a function, say you call recurse, right? Because it's recursion, right? And you create a function called that. And you come in and inside of that you call itself. And it'll come around here, and it'll just loop around, and it'll go recurse. And so inside of any recursive function, you've got to have a termination condition.
Okay.
So sometimes it's a really useful thing to do. So you come in and you go, I need to check this, I need to check this. So one place I used it back, Visual Basic, if you wanted to create a directory, and you've got C:\/ user /Graham K /docs, right? And you want to create this directory. If you asked VB to just create this whole directory, and this didn't already exist, it'd fail.
The camera died again. That was me telling them so that they know.
Yeah. So I'll cut out the recursion, probably.
You reckon?
Well, we see.
It was interesting
No,
for me.
with the recursion, we still. Whoa! If you just come down this tiny little bit, with the recursive thing, I wrote a function that was create directory, and it just come into the directory and it'd say, do we see a colon?
Right.
At that, and if it goes, no, it doesn't. So call again. So I'm trying to create this directory. It comes in and it looks at that, but it doesn't see a colon. So then it calls itself and it doesn't see a colon. Now it calls itself. It sees a colon. Now it goes, okay. Then it goes, comes back around. As it comes back around, the next time, after it loops way back, it creates that one, and then it creates that one, and then it creates that one.
Right.
And so it doesn't matter how deep it is. It'll come back and it'll create the whole tree.
Right.
So there's a recursive call that's a handy tool. But when you do it like this, it just, that we can't see.
You end up with
it just. But when you write a recursive call, you have to know how you're doing it and make sure you don't blow the stack up.
Right. Okay.
But what I was going to say is we're. All right. So we have the heap. So the stack is like that.
Yeah.
The heap is just a heap of memory. And then you, at any time...
Like a pile of socks?
Exactly. It's called the heap.
Okay.
And it's just a chunk of memory. And over here you can say, hey, I want this, I want a new one of these. And it just goes out of the heap and it grabs it. During runtime, it just says, give me this much memory off the heap. And it goes, there, you can have this much. There you go. And that's stored in a pointer. And the pointer is just an address in the memory. It says, if you want to find this thing, it's over there.
Okay.
And then, so you can go, I want a new one of those. Give me one of those. And you can ask for as many as you need.
Hey.
And then, later on, you can go, I don't need that anymore. So you go, equals null in C++. Or it goes out of scope, whatever.
Right.
And you can get rid of them.
Okay.
So it means that we can, with these characters, we can have a list of characters. But I'm going to use native data types. And I'm thinking of maybe using a dictionary for the characters. So we don't have to write our own classes, but at least parts of it I'll store in a, we'll have a look and see what it looks like. But, oh man.
This is magic.
No, poking the ribs is so...
No, don't poke me in the ribs. No. What do I have? There's a jam up here, don't worry about it. It's fine.
Failing, it's coming
It's
off.
fine.
Oh no! Oh no! The perfect system was never made for rewind.
It was never made for rewind.
So, as far as I can, I want to use native data types, and now we've got that pulled over. Oh, there it is.
It's fine. Everything's fine.
And
our system is flawless. Don't question
the
me.
joy of using those is that everything's written and I don't have to make sure it works because it's already written and tested.
Right.
So anything I can use that's part of the part of the programming language, I will.
Yeah.
But there are data types that are dynamic, and so you can add and remove, and so you can delete during runtime. You can create and delete. So all of that
will be good because I figure. So we've worked out that'll happen. It'll do its thing. It'll basically come back to a similar looking thing. It'll loop back to something that looks the same until more people get murdered and whatever. So right. But if we can delete these characters, well, not delete, but they're out.
Yeah, we can delete them.
So it deletes them, and that doesn't affect later on if you want to play it again. It's just like
no, because next time,
starts from
or
the
if you go start again and it comes around, and so if you've got a do you want to play again on the thing, it comes around and it deletes the old world, and it creates a new one, and the new one sets itself up, and everything's reset.
Great. And that's actually perfect because I was thinking about, because there has to be an end state, right, where it triggers an ending rather than looping back. And I figured those are probably going to be at the base level. There will be one where if the number of imposters is equal to or greater than the number of, not imposters, then the imposters win and you get an ending where the imposters win. Or if the number of imposters is less than 1, so like if there are no imposters left, you get a happy ending, right? And so it would probably have to check for those when it executes a murder or when when you have an airlock ejection.
Now, of course, when you do a murder.
Well, because when you do a murder, you could end up with multiple.
But is the imposter ever going to murder the other imposter?
No.
So
that'll never happen. But you could end up in a situation where the imposters win based on a murder. So it would need to check for an imposter win at every murder, and it would need to check for, I suppose, either an imposter win or a crewmate win on an airlock ejection. And then if it happens, it ends, and if it doesn't, then it loops back around. Hey.
But... So we desperately trying with multiple flat batteries.
Cameras died twice. We gotta rush through this.
But if you take all of these things and whatever your bit of this, I've cut it off, whatever. But if you actually make a game and you play, and like I said, you won't even need to con one of your siblings or parents into engaging in this. If you can play the game and note whenever there has to be a response from the computer.
Right.
Which will be literally the computer.
Right.
But now, if you play the game, you have over here a manual computer and you think, all right, it's got to offer me a choice, or it's got to do this, or it's got to do that.
Right.
And then you go, now I make this choice, and it's got to do this.
Mm-hmm.
And if you do it as a board game,
Mm-hmm.
and maybe you think you've got a dungeon master, in Dungeons and Dragons, I've played it twice in my life, not by my choice, I kind of roped in. But if you've got the dungeon master, they play the role, and in fact I saw on the great IT crowd where they run the the game with the visiting executives.
They're all crying.
Oh, don't do this. And Moss runs the game. But
the Dungeon Master is kind of being the computer.
the dungeon master is not kind of being the computer.
They're interpreting all the...
And there's a set of rules. And if you get to a point in a game, there might be that there's some complex thing, and the dungeon master might have to consult the rule book to say, well, under these circumstances, I can't remember how many sided dice I should and what the response is. But if you basically say the dungeon master is a computer, and you map everything that the dungeon master... So the dungeon master says, now we're going to... and so you set up a board, and the dungeon master says, now we're going to start. And then you say... And the dungeon master says, right. So the dungeon master says, look, which room do you want to go to? And then you go, I'm going to need a menu for that. But at that time, the dungeon master... Or the game.
I can even think of literally there is a board game that, like the end conditions that we just went through, in a board game called Dead of Winter, there's literally just a thing where at the end of every round, after everyone's taken their turn, you check against a list of things, and if...
Based on that.
And based on that, like, if all of these things are fine, then you go to the next round and you loop back. But if that's not fine, like, if you have reached
but
zero
even if you
morale, you've lost the game and the game is over.
But even if you don't, if you just talk about playing 500...
Yeah.
Effectively,
yeah,
that's what happens. At the end, it says like, has anyone?
Does anyone have 500 points? No, go
again.
Okay.
And at the end of each round, you add up the points based on how many hands you won and so forth. Every game is doing exactly this. It's implicit, and when you learn to play the game. I don't know why I put that in inverted commas. No, but when you learn to play the game, you learn... So what you want to do is you say, what parts of the game are down to the player and what parts of the game are down to the dungeon master in this case.
Right.
Or the process.
Yeah.
And what happens is in a normal game like 500 or something like that, the people... by themselves play the role of the computer. They do the score computing. They do.
Which I suppose you can apply to any. You can apply it to a game of tip.
Yeah.
Like you're running around, you're tapping people. That's the core loop, and then it's like, is anyone tired? Does anyone want to go home? If no, play again.
Yes.
Like,
It is exactly. So we're doing this all the time, but we're doing it implicitly. In any sport, any game, the referee gets to intervene and the players do their thing. So this is very familiar stuff. But this is, but what we have to do is, I think of it as, I guess, instead of all the players learning to play the game, you have to write the complete manual.
Right.
And the computer program is that complete manual.
And the computer will be the dungeon master for the game. Okay. I think I'm good. I get everything we've done. I think I do. But
yeah, and so what you need to do before we get together for next one.
When will we three meet again? You're the third.
And so if you can
try to make sort of a little prototypey.
If you run it and then make sure, just effectively write the rules for the dungeon master. If you want to, think of the computer as the dungeon master, and the dungeon master only interprets and enforces the rules. That's all they do.
Right.
And they say, right, now we're going to start. And now you, as we've got to decide who goes first, or we've got to, whatever. There's these protocols.
Right.
And so we then, what the algorithm then is that playing out of the game, and the algorithm then comes in, and so in there, in our main function, it'll go on there, and we'll have to work out how it all, the topology of it. Sometimes your name, sometimes your main function is really a couple of lines.
Yeah.
And it just calls up to this other function, or it goes into a class that's the master class that's running it, and the world could be the where all that stuff happens.
Yeah.
So you might create a world and then go play game, and then reset, and down in that bottom level, all you got is a little loop. Or you might put some of the more of the smarts into the game loop at the beginning. We see how that falls. But that's then if you can play the game yourself and make sure that you have documented, and there's our pseudocode.
Yeah.
And I want it so you start at the top, and the pseudocode, the algorithm, which you're going to write in pseudocode, I guess. The algorithm is the pattern.
Right.
And you express it in pseudocode.
Okay.
Is you come in, and then by actually physically doing this, you really start to open up your classes. You really start to open up what they need to do, how they need to react.
Yeah.
And then as you go through, if
and I'm probably going to
to
screw it up, but I'm going to try.
Yeah, but we'll be, we're moving on.
Yeah. Yes. Look at all the progress we made today. 2 people are dead.
But more importantly, this is how we solve. Doesn't matter whether I'm writing something to collect spectra and fill and pump out cells, or you're doing that, or you're writing something to edit a photo, or
Right.
record sound or whatever. It all, you were saying as we were coming back down here, it's almost like I could use this again. Well,
Yeah,
yes,
I could
of course
use
you
it
can.
for doing different things.
This is the way. This is ultimately, whether you're doing it with cards and whatever works for you as you think. For some people, they don't like to do this. Some people they do. But work out how you think and how you interact, and this looks like it really works for you. And you'll be surprised at what you can do. And once we've got this, then the final step is to then, and this is the thing, it might seem like we spent a lot of time, but the final thing you do at the end is actually start writing code.
Yeah.
That should be the last thing you do, not the first thing you do. It's really tempting to want to write a lot of code and make something happen. But if you haven't got all this worked out, you're going to hurt yourself.
Yeah. Neat.